There are many things that I can talk about, in particular all my fights with the Danish health authorities and the Danish Cancer Society and a number of doctors, but I'm going to focus on the research and the background for these, what we would call positive side effects. We haven't got to prove yet, but we'll get there. So, first of all, a little on the background. As you know, it was approved in 2006. 250 million doses have been distributed worldwide, which is what they always used to tell you, that there couldn't be anything wrong. We've sold that many doses all over the world. 650,000 girls in Denmark have been vaccinated since 2009, when it became available without charge. But there has also been a number of reports of side effects. Like in Ireland, I heard from Peter, it was said that it was a national thing, that it didn't happen anywhere else. We've heard the same in Denmark. This is a Danish problem. But as you can see here, I lined them up. You can see all these countries that have reported side effects so far. So it's all over the world. No doubt about that. So the program, what I'm going to talk about is the vaccines have what we would maybe called off-target effects. That's what the immunologists call it. And what have we seen in our clinic? How do we diagnose POTS, which is the main feature? What are the mechanisms involved in the vaccine effect? Because we have to go in to see what happens when you vaccinate a girl in order to find out where it went wrong, and in order to find the treatment. So the next thing is there autoimmunity in patients? What are the consequences of this autoimmunity? Is it myalgic encephalomyelitis? And what is the reason for the fatigue and fatigability in these patients? What are the treatment options and benefit conclusion? So, to start out, there was a Danish group in 1992 that worked in Guinea-Bissau, Africa, for WHO, and they discovered that when you vaccinate the infants in Africa, there are effects that are not expected. There are positive effects and there are negative effects. So this is on the positive side. If you give the live vaccine against tuberculosis, what you see is that it affects things that are different from tuberculosis. It affects their ability to grow, and they thrive better after the vaccine, irrespective of whether they have tuberculosis or not. So that was on the positive side of what they would call off-target effects of vaccines. Then we have the negative side, which is the killed or not live vaccine, and diphtheria. And this was a Danish anthropologist who started this discussion back in 1992, and he was forced by the WHO to stop publishing it. It came out in, that was in 2016. And what it shows is that if you vaccinate the infants with diphtheria vaccine, you have an increase in twice as many die in the institute by getting this vaccine. So this was something that WHO, of course, didn't like, because eventually it would mean that there would a number of African infants in Guinea-Bissau. So it took from 1992 to 2016 to get these data out. That just shows you that there are off-target effects, and we've known that for so many years. Even now in the peer-reviewed magazines, you can read that there are effects on the immune system that we would not expect if we give a vaccine. It might affect other parts of the body. It might also cross-react with other microorganisms. So there are effects aside from what they're designed to give. So I think that's sort of an established thing with immunology. It's not established with the health authorities, but it's firmly established among immunologists. So why do you get these off-target effects? There are two main reasons for that. One is what is called molecular mimicry. Are there things in the vaccine that mimics part of the human proteome so that we would respond with antibodies against ourselves? So we would get an autoimmune reaction. And then the other thing is, do we get a bystander activation? bystander activation is something that happens because we're all born with the ability of producing antibodies against our own body, which is weird, but that's the way it is. And during infanthood, most of these cells are killed, but some will remain in some people and not in others. And then when you get a very large increase in cytokines from the immune system, as you get when you get HPV vaccination, then you can sort of wake up these dormant cells, and they will start producing antibodies against yourself. So that's what they call bystander activity. And as you know, maybe you know that when you vaccinate with HPV, it has what we would call a very, very high antigen density. That means that the rise in antibodies is to about 10,000 times the level you have if you have a natural infection. So it's a really hard, a really solid stimulation of the immune system. And on top of that, you enhance it with aluminum in some form. So there's a great risk of getting bystander activity. But if you look at the first part, there was this publication by Dr. Campbell, who works in Italy. It was back in 2009, looking at possible cross-reactivity between HPV vaccine and the human body. What she looked at was a sequence of 7 amino acids. If you want to put 7 amino acids out of 20 in the right order, the chance of getting that, by chance, is 1 to 1 billion, more or less. So there's not much chance. What she found was 82 perfect matches between the HPV-16 vaccine and the human proteome. So she concluded that the number of viral matches and location make the occurrence of site autoimmune cross-reaction to the human host following HPV-16-based vaccination almost unavoidable. This was put out in 2009, and nobody has talked about that. So that's one of the possibilities of having molecular mimicry. So there are a lot of things in the vaccine that would say, well, it's no wonder that we might get autoimmune disease out of this. So that was just a little bit about the off-target effects in the background of that, and now to what we've seen in our clinic. This is just a case report. Typical case report of the first patients we got in. This is an 18-year-old woman or girl who used to play on the national soccer team. She developed burning pain and muscle weakness within 7 days after the first vaccination. After 6 months, she had progressive muscular weakness and chronic severe headache. She gradually developed orthostatic intolerance, fatigue, exercise intolerance, cognitive dysfunction, widespread involuntary muscle activity, and severe pain. She had to quit the studies at the university. She was dependent on help 24/7. Fortunately, she's not dependent on help 24/7 anymore. She's back studying again. She was diagnosed with POTS. So this sort of describes what the typical patients that we have. And the clinic, which was a result of this documentary you might have seen, the vaccinated girls. After that, the politicians determined that we should have 5 units to take care of these girls. So that was a positive thing because that made us able to gather a lot of data on these girls and give a good background for research. We were also fortunate enough to have at least one politician that supported us, and she was able to get us 4 million Danish kroner, which is equivalent to 600,000 euros for doing research. So this is what I'm doing now. So we've seen, we have had 830 patients referred. They're pretty old. Because we had a catch-up program in Denmark. A catch-up program that went all the way to 27 years of age, which is not the target that they should have aimed at all. I have one, and this is kind of strange. He's 73 years old, it's a male, and I don't want to criticize orthopedic surgeons, but his friend, an orthopedic surgeon, said we should have this vaccine. It's very good for prostate cancer. So, and we've been laughing about that. He's a very nice guy. He has a few side effects, but that's all we got out of the vaccine. So, and we have another example. There's a 91-year-old woman who was vaccinated, and I think that's a case for optimism, because it's a sexually transmitted disease, and it takes you about 20 years to develop cancer, so that's really the definition of optimism. So. But I've talked to 805 girls so far. Fortunately, a number of them have gone back to school or back to work, and I have about 150 girls left. So maybe this is spontaneous. I like to think that it's the treatment that I give them, but it might be spontaneous, we never know. The main symptoms that they have, you all know: orthostatic intolerance, insomnia, headache, cognitive impairment, fatigue, fatiguability, nausea, abdominal cramps, dyslexia, and neuropathic pain. So that's not the full list, but that's sort of the main features that we see. We published that in 2015. You can't read it, but you can read it there. So we made the conclusion that we found a consistency in the reports from these patients, and both our findings and what we've read from the literature, there was a consistency in that. It does not confirm or dismiss that it could be the HPV vaccine, but there's a temporal association between the vaccination and the occurrence of symptoms, and we thought that might be interesting to look into. And that sort of created what is not a nice word, but a shitstorm from the health authorities, from doctors, from gynecologists, from Cancer Society, and said that this was scientific fraud. All we did was we would tell them about our observations, and as you've heard before, you start with observations. Then you start looking for causality, but you have to observe first, otherwise it doesn't make sense to do any kind of scientific studies. So what we were doing is we were reporting our observations. This is the characteristics of the publicized cohort. About half of the patients had POTS. They were normal height, weight, and body mass index. 40% got their symptoms after the first vaccination, 35 after the second, and 25 after the third vaccination. The time of onset of symptoms was the mean 11 days, because we put a limit to how far away in time it should be from the vaccination. Not that it really matters, but for the sake of science, we had to put it like that. What was striking was that the level of physical activity was very high in these girls. Elite level means that you're training between 10 and 20 hours a week. And 1/3 of our patients were on the national team in their sports. So maybe there was a connection between training and this response. We know that if you exercise a lot, you change your immune system. Nobody really knows what happens, but because I've talked to the experts on this, and they can't tell me what's a good time for vaccination. Maybe there isn't a good time, but many would like to know if they're doing sports, should we take it when we are relaxing? And my recommendation is that if you're competing in sports, don't get the vaccination. But this was something that we thought about. So POTS was an important feature of this, and this is a subject that I've been working on for about 35 years. Autonomic nervous dysfunction is sort of my specialty. So this was something that we knew how to do. So it's quite simple actually. What we do here is we have patients lying down, then we ask them to stand up. The heart rate goes up because the blood pressure goes down. You can all try that later on. If you go up fast, then you will faint probably, especially if you hold your breath while you're doing it. So this is the normal response. You get this transient increase in heart rate, and then it comes back at a higher level, about 10 to 15 beats higher. The abnormal thing is if it rises above 30, when you're over 18, if you're under 18, you're allowed to have an increase in heart rate up to 40 beats. So that's the diagnosis of POTS. And you don't have to be a physiologist to see there's a difference in these two patients here. So this is a typical HPV patient. you can see the initial rise in heart rate, and then it stays up there, and then it oscillates. And blood pressure oscillates. And if you do that to normal subjects, you can put them in what we call a lower body negative pressure chamber, and then we can oscillate blood pressure. And what happens is, if you do a mental arithmetic test before and during, they totally fail. They get mentally fogged, they say. They can't concentrate, they can't work, their cognitive ability is gone. And what happens is that the normal coupling between flow and activity in the brain isn't there anymore. So you cannot send the flow to where the brain is running. That is sort of the background of the cognitive problems that you see in patients with POTS, and that you see in HPV patients. At least it's part of it. Because it's not we, it's an American group that has reproduced this in normal subjects. So. And if we do TIL test, as we also do, a little more sophisticated, but it's sort of the same response. You have patient lying down, you tilt them up to 60 degrees, you get a slight increase in heart rate, you get a slight increase in blood pressure. If we want people to faint, we give them nitroglycerin at the end, and then most of them will faint. But that's not the point of that. But if you look at a patient with HPV, you can see here again, you have an increase in the heart rate from 70 to 122. But it's not just the increase in heart rate, it's also the oscillations in heart rate and blood pressure. So there's more to it than that. And there are more forms of POTS, like this girl here. She has what we call inappropriate sinus tachycardia. That is, she has a high heart rate in the resting position, and it goes up to 237. And if you get above about 150 when you're standing without using your muscles, you're bound to faint. Anybody will faint with that heart rate, because the time of filling in the heart gets too short, and the pressure is too low, and then everybody will faint. That would be a normal reaction. We can provoke that in anybody by increasing the heart rate sufficiently. We're not doing that very often, but we can do it. The other one here is a special case where you don't see such a high increase in heart rate, but still the patient responds, because you see these oscillations. And the reason for not having such a big increase in heart rate is because the blood pressure increases, and that keeps the heart rate down. But still, this patient has POTS, even though she doesn't fulfill the normal diagnostic criteria, because you have these oscillations in blood pressure. So it might be a little complicated to figure out, but it's not that hard. I think that most doctors would be able to do this. So, in order to find out, I mean, this is something that you can't simulate. You can't tell your body that now I want to have my heart rate to increase and oscillate. That's impossible. So that's the first objective sign of there is something going on there. That's what the health authorities would like to have. We like to have something objective to look at. So we've created that. Now, why do they get POTS? Why do they get POTS, and why do they get all the other symptoms? So we had to go back and look at what happens when we vaccinate people. This is a bit busy slide, but we start up here. You have the antigen, which is HPV code, and then you have the antigen. And it connects to some receptors on these immune cells that are called dendritic cells, and eventually it ends up down here and it's presented to the white blood cells, and then it can go in either these two directions, either this one, which is the cellular immunity, is what you stimulate if you have a live vaccine like the BCG vaccine against tuberculosis, or you can go the other way where you have the HPV vaccine where you create antibodies. So, and because of increases in these cytokines, you may get bystander activation, what I talked about earlier. So, what is special about the HPV vaccine is this monomer here would create an antibody. Then you assemble them into a capsule. We have 5 of those, and then you put it into the virus-like particle, which is the vaccine. So you have a very high density of antigen. The first thing that we looked at was this part, how the antigen is presented to the white blood cells, and we found that, let's see, there we go, we found that this human leukocyte antigen, which is something you inherit, was significantly higher in one of these antigens that predisposes you to get autoimmune disease. This is an antigen that you would find in gluten intolerance, you would find it in diabetes, you would find it in a number of autoimmune diseases. So this was sort of the background. Now we know that there's a genetically difference between those that get these side effects and those who do not. The next thing was to look at the antibodies. And the first thing you do when you look at antibodies is to look at sort of general activity in the immune system. And one of these is what is called anti-nuclear antibody. It's non-specific, but it's there. It signifies whether you have an immune condition. So in our sample of 83 girls, we found that the antibody was positive in 60%, compared to 25% in control. So there was something going on in the autonomic nervous system. Now we have to figure out what's going on. What is it specifically in the autonomic nervous system that is going on? And so we looked at the literature, and we looked at, from a group in the US, looking at POTS patients, and they were looking at these receptors. These receptors are a kind that's called G-protein coupled receptors. That doesn't matter that much, but that sort of, gives us the story. And what you've seen here is that the cytoplasm, I don't think you can see it, it's light green here. This is the nucleus. And then you add an antibody against this receptor and it lights up. And then you add IgG from a POTS patient, and then it also lights up. And that's sort of a proof that these patients have this antibody. So we would follow up on that, look at the G-protein coupled antibodies. And I would think that I've never heard about G-protein coupled antibodies. I don't know if you have, but I hadn't at that time. So we had to go back in time and look at Graves' disease. Many of you probably know Graves' disease, and many of you know this guy, because he looks like Marty Feldman, He died at 82, but he was a very funny guy. He has Graves' disease. He has goited the show, and he has these eyes. The receptor responsible for that is the G-protein coupled receptor. It's the classic autoimmune disease. So we went for these receptors. We found the guy in Germany who is the world expert on analysis of these receptors. And what he tells us is that in the nervous system, we have transmitters that are going to send the signal from the nervous system to the cell that's going to respond to it. So it sits on a receptor here. And all of these receptors are G-coupled receptors, G-protein coupled receptors. We have 800 of them in the body, so they're widespread. And that's one of the things that we were looking for. We were looking for things in the body that would cause a lot of different symptoms. What the antibody does is, the normal thing is that you put the transmitter on the receptor and then it, for example, increases heart rate. Then the receptor and the transmitter is internalized, and then the stimulation stops. And then it's ready for the next stimulation. So this is the normal way. For example, when you stand up, like I showed you before, you get this transient increase in heart rate. So you have more transmitters and the receptors, and then they disappear, and then you get back to the normal level again. But what happens in the girls is you have an antibody that sits there and stops the receptor from internalizing. That means it has a constant stimulation of the cell. And that's why heart rate remains, that's what we think, it's why heart rate remains high. And that happens in all organs, but heart rate is so easy to measure. So what we do is, what he does again in Germany, is he takes out cardiomyocytes from newborn rats. Cardiomyocytes from newborn rats, if you feed them right, the cells, they keep on beating. So this is the spontaneous beating rate of this. And what you do then is you have a basal rate of about 150 beats per minute. You give not the antibody, but the IgG from the patient. So you take the blood, the plasma from the patient, drip it on the cells, and then you see that the heart rate increases to 230. Then you block it with a beta blocker, and then it goes down, not all the way down, because there are more than beta receptor antibodies in this preparation. So that was sort of the in vitro measurement of these antibodies. By chance, we did a biological experiment. It was not intended to be so, but there was this patient who's she had asthma. She had been vaccinated. She had a lot of symptoms. She fainted when she used the asthma spray. So a doctor asked us to look into this and do a tilt test when she got the asthma spray. So we tilted her up. She was doing quite all right until she took her first dose of salbutamol, which is the standard beta-2 receptor stimulant that you use for asthma. And as you can see now, she starts to oscillate, both in the heart rate and the blood pressure. Then we ask her, which is usually the procedure, to take another, go at the spray, and spread right here, and she faints. She has this blood pressure. We turn it down at this point. She's out for half an hour. And this is sort of the biological equivalent of giving a beta-2 receptor stimulation to a patient who has a beta-2 antibody. So what happens is that she takes a spray, it sits on the receptor, but the antibody keeps it there. And what it does is it increases heart rate, but it also dilates her vessels. Beta-2 receptors on the vessels, so she has total vasodilatation, and due to that, blood pressure falls and then she faints. And it takes her half an hour to get that. We are not going to repeat this experiment because it was not our intention to do harm to her. She wasn't harmed, but it sort of illustrates what happens. So the next question is, what does it mean that we have these stimulating autoantibodies? Well, it means that your cells are, now you can photograph, your cells are overstimulated. And if we take all these different symptoms, many doctors will say if you have 20 symptoms, there's something wrong up here. That was also my first reaction when I saw the first patient in 2011. But when we got more patients, then my reaction changed. Usually you would say that this is a functional disease, which means that you're crazy. But you're not. But if you rearrange the symptoms, you can say, well, we know that there are antibodies that stimulate the sympathetic nervous system. What happens if you do that? You get palpitation, you get tremor, you get almost intolerance, you get insomnia, you get fatigue, you get cognitive dysfunction, you have headache, migraine, and visual disturbances. That can all be ascribed to stimulation of the sympathetic nervous system. Now, if we look at the stimulation of the parasympathetic nervous system, we also found an antibody that stimulates the parasympathetic nervous system. Then you get nausea, abdominal cramps, constipation, and a hyperactive brain dysfunction, which means that you have to run out to the toilet at least once every hour, even during the night. Not a number of my girls have had that, or not my girls, but my patients. And stimulation of the final, this is a nociceptin opioid peptide receptor that nobody before had described any antibodies against. But that sort of explains the pain, the involuntary muscle contraction, and the enhanced inflammation. There are many girls that tells us that they have fever for a day, two, then it goes away. They get the heat waves, so they think they are about to have menopause, which they're not. But this, in my mind, is the release of cytokines. The cytokines are the molecules that tell you whether you have an infection or not. Okay? And so if you stimulate the NOP receptor, you get enhanced inflammation. So I think that almost all symptoms that the patients complain about, we can classify them as being ascribed to one of these three antibodies. And not everyone has all three antibodies, so there will be a difference in their symptoms depending on what kind of antibody they have. That's at least our theory at this point. In order to prove our theory, we have to remove the antibodies and see what happens. And we're not there yet. We're trying to get there, and you will hear that at the end of this. Yeah. So one of the consequences of this autoimmunity, is it chronic fatigue syndrome? Is it myalgic encephalopathy and encephalomyelitis? Well, we know that these patients here, they have the same antibodies. We know that POTS patients have the same antibodies. We know that complex renal pain syndrome patients have the same antibodies. So there's a lot of similarity. It's not the same diseases, but there's a lot of similarity in them. We published a paper also in 2015 where we concluded that 87 to 90% of our patients fulfill the criteria for chronic fatigue syndrome in me, according to the criteria that we have. So there's a lot of overlap, which is good because then we can profit on the studies that have been done in chronic fatigue syndrome. And I don't know if you know it, but the NIH in the US has put out $95 million for studies on ME and chronic fatigue syndrome. So there's a lot of interest in that, and we try to profit from what they come up with. So if we look at the data from that, this is just, what is the reason? Well, this is a stimulation of the myocardial cell, a cell from the cardiac cell, and what we see here is the energy production. And when you stimulate the cell by stimulation of the receptor, you get this response, range over time. But when you add plasma from the patient, from the forehead, you get this response. So you amplify the response. You get 3 times the response in this given cell if you add plasma from the patient. That means you're pushing the cell, you're pushing the metabolics in the cell. And if you do that, then they will produce what is called reactive oxygen species, which is very reactive chemical substances that will damage the wall in the mitochondria. The mitochondria are the ones that create your energy. So the mitochondria are these small little guys. They're all over the place. They're in the brain, they're in the muscles, they're in all kinds of tissue. And they're the ones that produce the energy. And they have a lot of enzymes in here. It's very complicated. Fortunately, I have collaboration with some biochemists who knows this, and they are doing a study for us now. So we are doing a study on mitochondrial function in the HPV girls. So what they say is that if you create these reactive oxygen species, you damage the wall, and if you damage the wall, all the enzymes fall off, and then you can't produce the energy anymore. And this is a picture that you wouldn't like, and that's the reason why I had to hire somebody to figure this out. So I've changed it into this. So when you have glucose, when you have carbohydrates, this is the way you usually change that into carbon dioxide and water, and you produce ATP. But if you do not have your mitochondria, instead you produce lactate. That hurts. So you have lactate in the muscles, and some will tell you that they walk maybe 100 meters and it feels like they've been running a marathon. And that's due to this increased lactate, and when you increase lactate, you're unable to contract the muscles because you don't have energy, because you only produce a tenth of this energy, which is called adenosine triphosphate, which is the energy you produce in your cells. So if you don't have your mitochondria, you're down to about 10% of that production. So that gets you to be tired. And if we look at the ability of patients with chronic fatigue, 0 is that you're bedridden, and these are normal controls. And you look at the mitochondrial energy score, which is something that we are about to finish our study in HPV, and this is from chronic fatigue syndrome. You can see there's sort of a linear correlation between their ability and their production of energy from the mitochondria. So what we think by now is that we have these autoantibodies that stimulate your cell to a point where the mitochondria dies. And when they're dead, you're fatigued and you're unable to do anything. And if you try to do something, if you try to exercise, then you kill more of the mitochondria, and then it gets worse. And that is what some doctors really don't understand. They would say to the girl, well, why don't you get up and get going? Come on, you've been a sports girl before, you can do it again. And you know they can. Because if they try to do it, they may stay worse. And even some of the girls would try it by themselves. Because they are driven girls, they want to do this. And they realize that if they try to run, I had one who tried to run a half marathon, she had to be carried away and she was in bed for the next month. So don't do that. That's not a good idea. You have to respect that you have these antibodies and that they would cause the fatigue in the cell. And this is a way to show it that even the health authorities might understand. This is a measurement of your maximum oxygen uptake, which is something you do on a bike or on a treadmill with a mask on. You measure when you start producing more CO2 than you use O2. So then you reach your what we call anaerobic threshold. It's not something you can think. It's not something that you can change by mental activity. And you do this on two separate occasions. This is day 1, this is day 2, and if you do a long study, you can reproduce it more or less. But if you have chronic fatigue or HPV side effects, then you're unable to reproduce your maximum oxygen uptake because your mitochondria don't work. So this is a measure of the global function of your energy production. So just the fact that you exercise on maximum exercise test day 4 means the next day you're down to 40% of what you could do the day before. So this is sort of the scientific proof of fatigability, that if you do something, you're paying for the next 2 to 3 days. So what are the treatment options? And what is my time? Is that okay? Thank you. What are the treatment options? Well, this is what I do. I have to stabilize their orthostatic intolerance, and I do that by asking them to eat salt and take fluid. I add to that fluorocortisone if salt and fluid is not enough. The idea being that if you stand up, your blood sort of accumulates in your legs. You've all been out, I guess, flying and have problems getting your boots on when you get off the plane because there's a lot of water down there. So in some patients, this would give them orthostatic intolerance. So one way of doing it is increase the fluid. It's fairly easy. It doesn't help to increase the circulation part. If there's not enough water in the central region, it doesn't help to increase the rate of the circulation part. Definitely what I'm saying. And it doesn't give you heat on the upper floor. You have to put more water on it. And that's the same with the humans. You have to put more water on it to get enough blood flow in the brain so you can function in the upright position. So that's the first thing that we do. And the problem is that you have to be you have to be able to wait for at least 4, 5, 6 weeks before it really works. Many doctors would say, well, we give fluorocortisone for 5 days and they were hospitalized. It didn't work. No, it doesn't work. It takes 4 to 6 weeks. I've done studies on that way back, but that's the way it is. Then we give a propranolol. That's the first choice because it blocks the beta-2 receptors. It's one of the only beta blockers that blocks both beta-1 and beta-2 receptors. Most doctors would prescribe beta-1 selective, but that doesn't really help the patients. So we have that option. We have a lot of other options to control heart rate. We can contract the vessels by lidocaine, which is a specific contractor of the skin vessels. So to get less orthostatic intolerance. We can block the M2 receptors in the bladder. We can block the M2 receptors in the ventricle. We can help their irritable bowel disease. A lot of these girls have that. I don't know if that's the same thing. It probably is. We have things that we can use. Peppermint oil is actually recognized by the medical profession as the best drug for pain associated with irritable bowel disease syndrome. We give melatonin or promethazine for sleep disorders, and then we use cannabis oil for pain, because we're allowed to do that. The future is immunoabsorption. We have to get rid of these antibodies because we actually don't know whether it is the antibodies. It's just a theory so far. I think it's a good theory, but we have to have the final proof by removing the antibodies and seeing that the girls get better. You can do plasmapheresis, which is not a perfect solution. In immunoabsorption, you sort of suck out the antibodies. In plasmapheresis, you take plasma out from the patient and give it from another patient or a control subject. There might be antibodies in there. We don't know. You can give high doses of immunoglobulin. Doesn't really work. And then this is what we hope will be available to us within the next year or so. This is a drug that shows German sense of humor. It's from Berlin chemistry, and it's a 007 because it has a license to kill all the antibodies. So what it does, it takes away all the G protein coupled antibodies, and it's just an infusion that lasts about half an hour. And if you do that to dogs, they still have no antibodies a year after the infusion. It's almost too good to be true. But they've tried it in normal subjects, and there are no side effects. We've heard that before from somewhere, I don't know where. They guarantee me that there are no side effects. So it's with the German medical authorities to figure out whether we would be allowed to do what we call phase 2 projects where we take patients in. So I'm very positive, and I hope that will come through. This was just the antigen-specific immunoabsorption. The reason why we don't do this is because, each of these columns here, each of the columns cost 5,000 euros. You have to have 5 in the series, and you have to repeat the series. So it's 25,000 euros for each series, and maybe you have to have 3 of those. So I've tried it. I hope that I'll get 2 of my patients through. These are patients who are bedridden 24/7. There's no other options. We've tried all kinds of treatment. So I said, why not just try it? Because it's so expensive to have the girls in bed and not doing anything. It's far more expensive than paying for this. I hope to get through with it, but it's difficult because it's another department and in another hospital, and they have a budget and so on. So we have sort of a proof of concept because this has been done in 10 patients with chronic fatigue syndrome with these antibodies. And they did immunoabsorption, and it provides evidence that immunoabsorption can effectively remove beta-2 and M autoantibodies and can result in rapid, moderate, mild symptoms improvement. So, and they asked for large-scale trials. So I think we're about to get there where we can do something. Take away these antibodies, and it seems from this study that it will work. We don't know, but we're hopeful that it will work. So, in conclusion, our studies so far point to an autoimmune condition occurring in temporal association with HPV vaccination. This is a real research way of doing it. I can't say that it's a side effect because that would be unscientific to say, but I believe it's a side effect. Whatever. The condition likely requires additional genetic environmental factors and may not be specific for HPV vaccination because we have these patients with chronic fatigue. One of the possible suspects or the suspects in chronic fatigue is Epstein-Barr virus. It's again an overstimulation of the immune system. So I think it might be a non-specific reaction from the immune system in patients that are prone to get these reactions. I don't know yet. The autoimmunity is primarily directed against receptors in the autonomic nervous system. We can obtain symptomatic improvement, and I like to think that has gotten a number of the girls back to sort of normal conditions or tolerable conditions where they can go to school or they can go to work, and they might be fatigued like Carsten told you about, but we haven't removed the fatigue from the girls that you have, but we hope to do that. So immune absorption or similar methods may be the treatment of choice in long term. And with that, I'd like to thank you for your attention.
Dr. Mehlsen.